Vygotsky was born in a well-to-do family in 1896. He developed a theory known as social development theory. He stressed that community played a central role in development. This theory was divided into three categories: human development, cultural theory, and the development of thought and language. In the area of development, Vygotsky stated that children learn based on cognitive development and the teachings of adults. If there is a gap between the level of cognitive development and the level of teaching, this area is called the zone of proximal development. The most effective way to bridge this gap of development is to have effective teaching so that children will better understand the content. Vygotsky also states that a child's development is based on the culture of the child. Their interactions with adults of their culture is greatly impacted on the way they think, act, and reason. The development of thought and language basically states that there is a direct connection between speech and learning concept. For example, children that discuss a topic are better understanding of the topic. In 1934, Vygotsky contracted tuberculosis and passed away at the age of 38. As a result, his work was left incomplete. In the 1980s, when Vygotsky's work became well known in the United States, Jerome Bruner further developed Vygotsky's concept of scaffolding. This concept identifies steps that are essential for effective teaching, such as arousing interest, creating simplified tasks, and allowing interpretations of the activity so that children can solve problems. Quantum entanglement is a quantum mechanical phenomenon in which the quantum state of two or more objects have to be described with reference to each other, even though the individual objects may be spatially separated. This leads to correlations between observable physical properties of the systems. For example, today we are going to learn about animals. In case you've forgotten, this is a raccoon. You can tell it's a raccoon by the mask on its face. We also are looking at a picture of a skunk.
Good morning, my precious students. Today, we're going to talk about the distance formula. But let's go over what we already know, alright? Looking at this graph that I've already drawn right here, can you tell me what this line will represent? Yes.
The x-axis?
Very good. We're just going to go ahead and write that right here. What about this line right here? Okay.
The y-axis?
Very good. You're so smart. You guys are very good at remembering things. So if I was to give you a point, like this one right here, what would this represent?
The x.
Very good. So I'm just going to write that right there. What about this one?
That'd have to be the y.
And very good. Now, Heather, since you've been doing so good, will you come up here and plot these points for me?
Well,
very good, very good. Okay, so when I say we're going to find the distance, we're going to find the distance this point and this point. Okay, so I'm going to draw a line between those two points. Now this is our distance formula. Look how easy and simple this is. We already know what the x represents, and we already know what the y is. Okay, so if this is our point 1, this is going to be x1 and y1. So what about this one?
X2 and Y2?
Very good. So catchy. Alright, so now that we have our x1, y1, x2, and y2, all we have to do is plug them in. Now, Heather, would you like to come up here and write me out the distance formula with these plugged in?
Distance equals the square root of 1 4 5 squared, right? Plus 7 minus 3 squared.
Very good, very good. So what is 1 minus 4?
3, negative 3.
Negative 3. What is 7 minus 3?
4.
4. Can you tell me what negative 3 squared is?
9.
Very good. What about 4 squared?
15.
Oh, you're awesome. What's 9 plus 16?
25.
Very good. And that equals your distance formula after times square root of 5.
Which is 5.
Very good. You did such a good job. Now you need to talk out through these and do this on your homework, okay?
Okay.